Bearcats, we are going to start on our review sheet tonight. Now you're supposed to have the entire review sheet done by Wednesday. I'm going to do a fourth of a problem each night, every night, for 4 days, and then we will have the whole thing done. So let's get busy on the first problem. We need to factor completely. Number one, I don't see any common factors. I know that this is the difference of squares, or DOS, and so I'm going to do two parentheses, one with the plus, one with the minus. In order to get 49, that's 7 times 7. P to the fourth is P squared times P squared. Minus 9Z squared would be 3Z and 3Z. Now I'm always supposed to try to go on if I see a square. However, 7 and 3 are not perfect squares, so that means I am finished. Number 5. Number 5, the first thing I have to do is get rid of that negative sign. I cannot factor with a negative in front. So what I'm going to do is take a -1 out in the beginning. So I have -1 parentheses. 3x squared minus 26x plus 16. Next, I notice that 16 is a perfect square, but 3 is not, so this is going to be a slip inside. So I'm going to slip the 3 out to the right, not forgetting to slide it in a little while. Now I have -1 x squared minus 26x plus 48. Now I'm trying to think of two things that multiply to give me 48 and add to give me -26. That would be 24 times 2. So now I have -1 x minus 24 and x minus 2. They both need to be negative so that when I add them together, they add to give me -26 and multiply to give me positive 48. Don't forget to slide. I'm going to slide the 3 back under. Now I have -1 x minus 8 because 3 goes into 24, 8. Now I can't have a fraction here, so I've got to multiply both of these by 3. That gives me 3x. These 3 cancels, and I have left -2. Now I'm going to number 9. I don't have a greatest common factor, but this is the difference of two squares. So I'm going to take half of the x's and put them at the front, and half of the x's and put them at the back. I need a plus and a minus, and 4 times -4 is 16. Now I have another even exponent. With even exponents, I have to try to keep going. Well, the 6 is even and the 4 is a perfect square, so I'm going to get x to the 6 plus 4. Now I've got to break this into two parts, 1 plus, 1 minus. Half of the x's go here, half of the x's go there, and 2 times -2 is -4. And I'm done. Remember, at the beginning, you can't have a sum of squares. It has to be a difference of two squares. Number 13. I notice that x to the fourth is even, and it's a perfect square. The 16 is also a perfect square. So I think this could be a perfect square trinomial. Half of the x's go here. 16 is 4 times 4. And if I multiply that, I get 4x squared, and double that, that gives me 8, so this is my final answer. Moving on to number 17. I have a golf ball struck from ground level. It's going to go up and come back down. Now on number 17, you are going to have to go into your -b over 2a. So that will give me the vertex. Now the vertex will tell me the time it takes to hit the highest point, and then it'll tell me the total time. Once I plug it back in, then I can figure out how long it's in the air before hitting the ground. All right, so I'm going to do -b over 2a. That'll be -200 over 2 times -16. A is -16 and B is 200. Dividing that out, or actually multiplying, I get -200 over -32. When I divide that, it gives me 6.25. So here's what we have here. We have that it takes 6.25 to reach the highest point. Now, if it takes 6.25 to reach the highest point, if I double that, then that's going to give me when it hits the ground. So it's going to hit the ground at 12.5 seconds. Okay, did y'all follow that? Well, the vertex tells you what the highest point is going to be, the time of the highest point. Since the vertex is halfway in the middle, then I have to double the vertex, and that will tell me when it hit the ground. Okay, number 20, someone asked me about today, so I'm going to go ahead and do this one. I have 3 things that I have to do. It says to first find the time, it says to graph the function. I need to find the time it takes to reach the maximum height, and then the time it takes for the soccer ball to return to the ground. All right, so I'm going to first do negative b over 2a to find my maximum height, the time of the maximum height. So that's going to be negative b, which is negative 48 over negative 16 times 2. So that gives me 48 over 32 reduced, or 1.5. So if I go over here to 1.5 and draw a dotted line, that is the time it takes for it to reach the maximum height. So the first thing I have done is found the time it takes to reach the maximum height. I'm going to call that A. So A is going to be 1.5 seconds. Okay, now I also need to find the maximum height. In order to find the maximum height, I'm going to take the 1.5 and plug it in for x here and here. So that gives me negative 16 times 1.5 squared plus 48 times 1.5. If I put that in the calculator, the answer is 36 feet. So 1.5 and up to 36 feet is about right there. Now, the time it takes, so the maximum is 36. Now I need to know how long it takes for the ball to return to the ground. Now what that's saying is it started at 0. It takes 1.5 seconds to reach the top. It takes 1.5 seconds for it to come back down. It's asking you for the total time it takes for the ball to reach the ground from the time that it was released. And that would be 3 seconds. So we have our graph, our A, B, C, D. We are good to go. Okay, so for number 23, I've decided to do this problem. We have the height of a baseball thrown upward with an initial velocity of 10 feet per second from 6 feet above the ground. So here's our initial velocity. Here's our 6 feet above the ground. How long does it take before the ball hits the ground? I know you don't have a calculator at home, so I have loaded the scratch pad right here. I've plugged in f of x, 16x squared plus 10x plus 6. What would be the next thing I need to do? Well, I need to see when the ball is going to hit the ground. I can't tell 100% where that's going to hit, so I have done Control T in my calculator. Oh my goodness. In my calculator so that you can also look at this. Now, can you tell where it's going to hit the ground? Right here at 0.6 is showing you where it started from. 1.0 is the actual point of where it's going to hit the ground. So therefore, it takes 1 second to hit the ground. Now, can you tell me when it happens to hit the highest point? That would be at 1/2 of a second. Next, we're going to look at number 25. We have to find the zeros of the quadratic function, looking at the graph. So this says label the roots. Okay, this and this are considered zeros. They're also called roots. They're also called solutions. Can you think of anything else? One more thing, they're also called x-intercepts. So all of those words are interchangeable at this point. My zeros and my roots, this hits at -1, and the x value is 1, 2, 3, 4. So my first thing I had to do was find the zeros, and they are -1 and 4. Now, you would not put parentheses around them. You are just listing them out, -1 and 4, or comma 4. The y-intercept is right here, which is -8. It says to label the y-intercept. The vertex is right down here. And I will just tell you that this goes down to -12. So my vertex, it does ask me to label everything. My vertex would be 2. Oh, wait a minute. Hold on. Where does this vertex occur? I can't really tell, so I'm going to have to do the -b over 2a. So a is 2, b is -6, and c is -8. -b over 2a is going to be -6, which is +6, divided by 2 times 2, which is 6 over 4, or 1.5. Then I need to take my 1.5 and plug it back in. So that gives me 2 times 1.5 squared minus 6 times 1.5 minus 8. I'm taking this 1.5 and plugging it in. That will give me -12. So the vertex here is 1.5, -12. I really couldn't tell exactly where it was, so I had to go ahead and use my formula. All right, let's see. I've labeled everything. My axis of symmetry, I haven't done that yet, and it's going to happen right at 1.5, axis of symmetry. Okay, my domain is going to be all real numbers because it's from -infinity to +infinity. My range is going to go from my lowest point, which is -12, up to infinity. Now another way to write that would be y is greater than or equal to -12. Next, I'm going to look at number 29. I've got to compare 3x squared plus 2 to x squared. What I need you to do is talk about 3 things. You need to make sure you can bullet 3 different things. You need to talk about if it goes up or down. You need to talk about the width of the parabola, using the words more steep, less steep, more narrow. And then you need to talk about the vertex. So let's talk about 3 things. The first thing is g of x is going to open up, the same as f of x. Number 2, it is going to be more narrow than f of x. And the third thing is g of x is translated up 2 from f of x. The reason I can tell all these things, again, if it's positive, it's opening up, that 3 is greater than the 1 that's right here, so it makes it more steep, and the 2 is added to from the x squared that's here. Okay, now on this problem, we have to find a lot of different things. The first thing we need to do is find the vertex, then the axis of symmetry, the zeros, the y-intercept, the domain, and the range. Now I'm going to do this just by hand so that you make sure you understand, and I will also show you on the calculator so you can see what it looks like on the calculator. All right, my vertex x value is -b over 2a. So that's going to be -12 or +12 over 2 times -2. That's 12 over -4, which is -3. So my vertex x value starts with -3. Then I have to plug that in, so that would be -2 times -3 squared minus 12 times -3 minus 16. I'm plugging it in for the x here and here. When you work that out, that answer gives you 2. -3 squared is 9. That gives me -18 plus 36 minus 16, which is 2. So I've taken care of the vertex. It is -3, +2. So I'm going to go -3, +2, and put a dot for the vertex. Now it does say to find and label, so I'm going to label this vertex. The second thing I need to do is the axis of symmetry, which is x equal to the x value of the vertex. Then I need to put a dotted line straight up and down And that's done. Number 3, the zeros. I need to go to my calculator and locate the zeros. I've never done this before. We're going to try and see if this works. Okay, I have plugged in my formula for my quadratic, and I am looking for the zeros. So let's look up and down this table and see what happens. Moving up, I'm looking for zeros. Well, there's one right there. -2 is a zero, or a root, or a solution, and -4. So you can see right here that we have some zeros at -4 and at -2. So I know that so what is it asking for? The zeros are at -2 and -4. So I'm going to put those dots on there, -2 and -4. I now need to write down what the y-intercept is, and that y-intercept is the number -16. Way down here, it looks like I'm going to go way, 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 way off my graph. I hope that doesn't bother you. So sorry about that. Way down here at -16. I can also copy that across here, and line of symmetry says that it's the same on both sides, and I can draw the arrows going down. Did I answer all the questions? Oh, I have to do the domain and the range. Okay, the domain is going to be all real numbers because it's from -infinity to +infinity. Now, since this is going down, this has a maximum, and the maximum occurs at 2. So I have to put the smallest number on here first, and the smallest number is -infinity. The highest number is 2. You could also write that by saying y is less than or equal to 2. Well, that was a lot of fun. Thanks for joining me on that one. And that is all we are going to do right now. Come back tomorrow for more information and continue working on your factoring. Y'all have a good night. Bye-bye.